Yesterday we talked about observational studies and experiments. Okay, the differences between them, um, the parts of them. Well, not the parts of them, but kind of the parts of experiments: experimental units, factors, levels, explanatory variable, response variable, treatments. Right. Today we're going to get into. We're only going to talk about experiments now. Today, that's what we're going to do. We're going to focus on that. Well-designed experiments on the board. I have the parts of a well-designed experiment. Okay, because remember, where is it right here? Where is it? The only way to show cause and effect, the only way to show something causes something is by doing a well-designed experiment. We can't say something causes something without that. Okay, so even if we do a million observational studies, it doesn't matter unless you have let me see, unless you've done an experiment. Okay, an experiment is the only way for cause and effect. All right, Christian, are you ready? Hate to take 10% off the next test. Okay, so let's put the phones away. Let's focus up here. Okay. All right, so what are the parts of an experiment or experimental design? There's three big parts. Random assignment. Use impersonal chance to assign experimental units to treatments. This helps create roughly equivalent groups of experimental units by balancing the effects of lurking variables that aren't controlled on the treatment group. So if you do a medical experiment, these are done all the time. They want to test something out. I think I've created a pill that cures a headache better than anything that's out there right now. Well, I got to test it. Okay? How do they test it? If I have a pill that cures headaches better than anything that's on the market right now, anything you can get at Target or Walmart or a drugstore, CVS, how do I show it works? Well, what do I need to do? I have to give it to people, right? To prove it works. I can't just say something without proving it, right? Okay, so who do I give it to? Do I just give it to anybody? Can I just give it to someone without them knowing? I have a headache. Oh, here, take this pill. Right? Can I do that? No, that's very illegal. One thing. Second thing is extremely unethical, right? So you can't do it that way. So all of those things. So what I do is I do a study. I do an experiment. Okay. I gather people. How do I get the people? Putting an ad up, right? I put an ad up in the newspaper or online, on Facebook, on Instagram, to try to get as many people as I can. And I let them know this is what you're going to be doing, right? Here's the problem: is that random? The people that I get, it's not random, right? They're voluntary response, right? So in order to get around that, that's why number one is there: random assignment. When people sign up for the medical experiment, I tell them this is what I got. They think everybody is getting, oh, I'm going to try out a new headache pill. I'm going to try it out. But in reality, only about half of them are. What are the other half going to be doing? Something called a placebo, which we'll talk about today. Placebo is something that it's called a dummy pill. Placebo is a dummy pill, a pill that looks like the real pill, but it doesn't do anything. It's a sugar pill or it's a water pill, right? It won't do anything to you, right? So everyone thinks they're getting the real pill. Well, only half of them, or about half of them, are. Okay, how do I decide who gets the real pill and who gets the fake pill? What's that? Randomly. Yep, that's where random assignment comes in. right? I can't let them decide. Okay, I think I'm going to take the real pill. I think I'm going to take the fake pill, right? I can't let people decide. I have to choose for them, but I can't do it knowing people, knowing who I'm giving it to. So it's called random assignment. Randomly give it to them, and most of the time, the people who are actually giving the pill don't even know the person's name. You're number one, you're number two, you're number three. So they're just numbers. So they don't even know the person's name. They don't know the person. If they know the person, you can't get into one of these things. Okay? Because it's extremely important. It's the way to show that my pill works great. I want my pill to be on the shelf at CVS. Well, you have to go through this process. Okay? And if you don't, if they find a hole in your system, if they say, nope, you didn't do random assignment correctly, you got to do it all over again. And that takes millions of dollars. Literally, drug companies spend the most amount of money on something called R&D. R&D, research and development. Research and development. Research and development is they're coming up with new things. They're coming up with new things, better stuff, or brand new stuff, right? So that's where they spend most of their money on. So they don't want to have to go through the process again. So they do all of these three things as best they can. The second one is replication. Replication. Replication of the experiment on many subjects in different locations, etc. So if I'm trying to test a pill that cures a headache better than what's on the shelves at CVS, I'm not going to just test all males in Fresno, California, right? I want males, I want females, I want people from California, I want people from the East Coast, I want people from the South, I want people from the Midwest, I even want people from different countries, right? So I want as many different people and as many different genders as possible. So that, because if I only test people in the United States, they're going to be like, oh yeah, it works on Americans. But have you tried it out on someone from Mexico, someone from France, someone from China, someone from Russia? Have you tried it out on these people? No. So that's why they have to do that. Okay. So they get companies all around the world. That's why some of these companies, some of these big time pharmacy companies have offices everywhere around the world. Okay. So that's replication. Replication is they have to do it on many people in different locations. Okay. They have to have enough experimental units in each group so that any differences in the effects of the treatment can be distinguished from chance differences between the group. So if you have two groups, I want to make sure all the males don't go in one group and all the females go in a different group. I want to make sure that if there's a bunch of men in the first group, that there's a bunch of men in the second group. I want to make sure that just different things like ethnicities. If there's this type of ethnicity here, I want to make sure there's this type of ethnicity here, right? I want to make sure the two groups, the real pill and the dummy pill, are the same, look the same. Obviously different people, but it's going to look very much the same. Okay, that's what replication does. I want enough people, and I want to be able to so that if this group up here, their headaches got cured better than these people down here, I want to say the only reason was because of they took the pill, because it had to be the pill. No lurking variables. Okay, that's what replication does. The last one is control. Control is the dummy group, the group who gets nothing. Well, I can't give someone nothing, so I give them a dummy pill, water pill, sugar pill, just pill that does nothing to you, right? That's the control. For lurking variables that might affect the response, use a comparative design and ensure that the only systematic difference between the groups is the treatment. I don't want any lurking variables. So you got to make conditions as similar as possible for all treatment groups aside from the actual treatments. If we observe a difference between the groups, we want to know that it has to do with whatever we gave them and not something else, right? If they got a headache, I don't want to know that it was another reason why their headache went away, right? I want it to be just the pill. Once I can do that, then I can say, my pill works, put it on the shelves. Okay, until I do that, we can't. Okay, so those are the three parts. So when you're conducting an experiment, we don't conduct any experiments. All we do is design them. Okay, all we do is design them. So there's two parts to it. It's on the board here if you can, if you could see it. The first part is an outline, a picture. Draw me a picture. I'm going to show you what a picture looks like down here a little bit. Okay, draw me a picture with labels. Make sure to label it. This is what it looks like. And then you're going to do the write-up. How did you do randomization? Where did you do randomization? How did you do randomization, right? We've done that before with samples, right? We've done that in the homework. You had to get a random sample of 5 or whatever it was. So we've done randomization before. Replication and control are the new ones that we have to talk about, okay? Okay, so example, I want you to 2007. Read the example, do the 2 problems. Okay, read the example, do the 2 problems, and then we'll talk about an experiment. In 2007, deaths of a large number of pet dogs and cats were ultimately traced back to a contamination in their food, in some brands of pet food. Okay, the people who make it, the manufacturer, are like, now it's okay, we're good, we fixed the problem. Okay, but they have an issue. What's their issue? Yeah, before that though, why are they having to test? Exactly, the trust issue, right? Trust issue. When I was a kid, when I was in elementary school and even junior high and high school, I never had Carl's Jr. or not Carl's Jr. Was it Jack in the Box? Jack in the Box. Never ate Jack in the Box. The first time I had Jack in the Box was wasn't I think I was in college by the time I had Jack in the Box. The reason why was because I don't eat fast food. I do, unfortunately, I do eat fast food. When I was a kid, I ate fast food, but when I was a kid, there was a story in the news that some kids had eaten Jack in the Box. This was like 30 years ago, 40 years ago. Some kids had eaten Jack in the Box and they got sick and they died. Okay. That stuck in my parents' head. So from then on, they did not trust Jack in the Box. So I never even considered having Jack in the Box until I moved out of the house and I was on my own. Then I was like, I'll give it a shot. Nothing happened to me, but that trust was broken, right? That trust was broken during the pandemic or just before the pandemic. Chipotle had issues. They didn't kill anyone, but a lot of people got sick, right? A lot of people got sick right around the start of the pandemic because they had some bad meat. It was only in one location, and it was only for like it wasn't that much. They caught it pretty quickly, but still, they lost a lot of business. They're starting to pick it up now, but they lost a lot of business because of that story, right? So there's a trust issue here. This company, there's a trust issue. People don't want to buy this food anymore because they said, hey, it killed deaths of a large number. This is a large number too. Okay, so they want to get their trust back. So what do? They do an experiment to show everyone, hey, we're okay now. We're okay now. Now we're okay. So in this experiment, what would the treatments be? The new dog food? Yeah, dog food. Yeah, the new dog food specifically. Yeah, new dog food. Okay. What would the response be? Response is how I measure. How do I measure? A little bit nicer than that. Health. There we go. Health of the dogs. Health of the dogs. Yeah. Even if it takes them to even if it gets them sick, that's still a problem, right? We don't want to get them sick. We want to test the health of the dogs. We test them before, we test them afterwards. If they stay the same health, it's okay, right? Can we do this to like 2 dogs? Can we get just like 2 dogs and test them and give them the food and everything? That's not enough, right? That would be a problem with replication, right? So we got to get a lot of dogs, right? So this is what an outline looks like. This is what an outline looks like. Easy to follow. It's got arrows on it. It's labeled, right? So the outline, this is the outline of what they did. So they actually did an experiment. They got 32 dog owners. I don't know who these dog owners are, but they volunteered them for this experiment. Okay, people will do anything for money. Explain how you would carry out a completely randomized experiment to see if the new dog food is safe for dogs to eat. The dog will eat the assigned food for a period of 6 weeks. Okay, so they've done the first part. They did the outline. You see the picture with the arrows and everything? It starts out with 32 dog volunteers. They're not going to get to choose where they go, right? Randomly, they're going to be randomly assigned to 2 groups. One group will have about 16 dogs. They get the new food. They get the food they're testing. So they're the actual treatment group. Okay? The other dogs will get the food they've always been eating. Nothing different, right? Nothing different. At the end, they're going to check the health of the dog to be determined by a veterinarian. They want to see, are these dogs healthier than these dogs, or vice versa, or is there no difference, right? That's what they want to see, all right? If they can show that there was no difference, health between the 2 dogs was overall about the same, then it's safe, right? It's safe. They might do it again because 32 is kind of low, so they might do it again in a different part of the country or a different country or whatever. But that's kind of what it looks like. That's the picture, right? That's what we need. Okay. So now what we're going to do is we're going to explain. We're going to do a write-up. Okay. We're going to do a write-up for how they did randomization. Where and how did they do randomization? That's the first thing. Okay. Not what kind. Randomization. Not what kind of randomization. Where did they do randomization and how did they do randomization? So the first one is the easy one. Where did they do randomization? What about the dogs? I see dog, 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 dog. There's 6 dogs up there. Exactly, right where it says random assignment. So you don't have to write the word random assignment. You can put RA. Sometimes you just put RA. That means random assignment. Okay? That's where random assignment was done. They did a random assignment. Somehow they were able to randomly assign 16 here and 16 here. Okay, so we got to explain where. So we say randomization was done to assign dogs to either treatment 1, or treatment 2. Okay, that's where it was done. Randomization was done to assign dogs to either treatment 1 or treatment 2. Okay, that's where it was done. That's the first thing. The next thing is how it was done. Well, they didn't really say how specifically, so we're going to kind of what's the word? We're going to kind of not guess, but we're going to kind of give them a method. Give them a method that works. What would be a method that works that we hope they used? What's that? Okay. Okay. So let's go back to these guys here. We've done this before. How did we do these guys, and how are we going to do? Right? We needed a system first. Right? That's what we need to explain. Our system. What system would we use? Mm-hmm. There you go. Let's start. Yeah, let's start with that one. Number each dog. 0, 1 to 32. Okay, I like that. Mm-hmm. There you go. And then we can use a calculator to randomly pick a number. Use a calculator to randomly. Okay, so I tell the calculator to pick 16. Who do they go to? Treatment 1. Okay, use a calculator to randomly pick the first 16 to treatment 1. We'll say T1. Second 16 to T2. That's a method. That's a system. Okay? So we explained where and how. If I actually gave you a list of dogs, list of 32 dogs, you could do that system and it would work. Okay? We don't have to, but you could. That's good enough. Okay? Replication. Replication. Now, replication is usually the hardest one because for some reason, it's just students don't really remember what replication is. Well, if you don't remember, go back to the definition. It's right here. Replication. What does replication deal with? What does it say it deals with? What parts would I highlight? If I wanted to know about replication, which parts would I highlight in that 2 sentences, 3 sentences? Okay. Many subjects in different locations. Good. So that the differences in each might be right here. So we have to just talk about how many, the number. Okay, so let's talk about that. There were 32 dogs. And then we can say 16 in each group used for experiment. So number is important. Let's see what else. Enough units. Again, units talks about number. Doesn't talk about location, right? They didn't say where or how many or anything like that. So we can't really talk about different locations on this problem. In the future, we might on other problems. Yep, that's about it. Okay, there were 32 dogs, 16 in each group used for the experiment. Okay. Control. First of all, who was the control group? Was there a control group, and who was the control group? Treatment 2 was the control group, right? What made them the control group? Treatment 2 was the control group. What made them the control group? Exactly. Treatment 2 was the control group because they were given safe food. We hope they all get safe food, but they were given the one's been proven to be safe. Okay, that's the first thing. Who was the control group? Treatment 2 was the control group because they were given the safe food. Okay, so they're the one we're going to compare to. Okay, so let's see what else. What else does control say? Use a comparative design to ensure that only systematic differences make conditions as similar as possible for all treatment groups. Okay, so this is one that we might not need here. For example, if I'm taking a pill, again, going back to my pill, where that can cure a headache. If I'm doing that, is it important that the appearance of the pill looks the same for everyone? Yeah, right? It's important for that because if people say, oh, one's blue and one's white, right? They might think, oh, the blue one is actually the real one. Or some people might think, oh, the white one's actually the real one, right? You'd be surprised what the mind can do. You'd be surprised. The mind can control your body in ways you would never understand. So there are people who have gotten dummy pills, but their headaches went away. You're like, how did that happen? Because they actually believed they were getting the pill. It's called the placebo effect. You're actually believing. The mind will actually do things like that. So you got to have the same conditions. Now, does it matter on this one? Does that kind of thing matter on this one? Do I need the dog food to all look the same? Why not? Mm-hmm. Dogs don't understand. They see food, they eat it. They don't, dogs don't have the type of intelligence that humans have, so they're not able to decipher things like that. Maybe the owners will see it, but the owner is not going to tell the dog anything. It won't work. So yeah, so we don't have to worry about that here. But if it were humans, I'd make it look the same. Okay. All right. So that stuff you would put in there. Pill would look exactly the same, taken at the blah 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 time, whatever. Okay. Okay. So that is what the outline should look like. That is what the outline or the write-up should look like. Okay. So you have two things. So these questions, if they ask you to do a randomized experiment, which you guys are going to do in a second here, you need a picture labeled, and you need to explain the stuff here. Okay. Randomization, you're going to have to do that on your own because that's part of the experiment. So you're going to make up stuff that you would do. Just make sure it's stuff correct randomization methods. Okay. Replication, talk about that. Treatment, if it's a human, you're going to add a couple more things, but since it's a dog, we don't really have to add anything to that. Okay. So those are the components. Okay, so why is random assignment important? We've talked about this. In theory, randomization equalizes all the other variables, all of those lurking variables, all of these things here, all of these things here. How do we get rid of all of these things here? By using randomization. By using randomization. Okay? Because when people volunteer for our study, that's a violation of volunteer response sample. So how do we get around that? By not letting them choose which group they're in. We get to choose which group they're in. Okay, that's where random assignment comes in. Okay, all right. Okay, so first one I want you guys to do, example at the bottom. I want you to do this one from beginning to end, and we'll go over it. Okay, this is the first one. This is just practice. You know you need an outline with a picture and labels, and you know you need a write-up talking about randomization, replication, control. Okay, I'll give you about 5-7 minutes or so to do it, and then we'll talk about it, and then you can add to it, take away from it. Okay. All right, so let's take a look at what you guys got. Okay, so the first one. So a high school regularly offers a review course to prepare students for the SAT. Okay. This year, school will offer an online version of the same course as well as also the classroom version. We need to design a well-designed experiment that will allow the school to see which version is more effective, the online or the school or the classroom version, where you have to actually be in the class with a real teacher and everything, as opposed to an online version where you just work your way through the program. Okay. So 100 students. We said 100 students. There's going to be a treatment group. Okay. So the treatment group is going to be the online version. The control group will be the classroom version. All right. How are we going to measure? What's the response going to be? The variable. SAT scores. So we would say compare SAT scores. Or compare, probably better would be compare average SAT score, right? Compare the average SAT score of one group versus the other. So that takes into account everybody. Okay. All right. We're missing some things. What are we missing? There's two things that I can see that we're missing. Random assignment, okay? How many RAs are we going to have? 2. Where are RA going to happen? From 100 students to? Good. We need an RA there. Where else do we need an RA? Good. That's one thing. There's one other thing that's missing from the picture. There you go. The size of the group. Size of the group. Does it have to be perfectly 50-50? No. But you want to try to make them as close to possible. So we can say 50 students and 50 students. If you don't have 50 and 50, if there's 55 and 45, that's okay. We want to try to make them as close to 50-50 as possible, but if they're not exactly 50-50, it's okay. We just want a decent amount in each group. Okay, good. All right. Got an outline, got a picture, labeled it. Good. Now we're going to do the write-up. Now we have to do the write-up. The second part of it is the write-up. Talking about how did you do the RA? We know there's an RA. We know when, so that's the first thing. So we explain when do I do the write-up, or when do I do the randomization? Randomization is done to split students into two. What do you mean? No, you just have to say random. When is randomization done? When is randomization done? You have to say when and how. Okay? When it was done to split the students into two groups. Treatment 1, treatment 2. Okay? How it was done. Well, this is your experiment. So as long as you can't poke holes in it, you can do it using the calculator. You can do it using the table of random digits. You could even put 100 kids' names in a hat and pick out the first 50. The first 50, that's my online group. The other 50, that's my classroom group. You can do it that way too. However you want to explain it, as long as your explanation is correctly done. Like I said, there's many different ways to do a sample. Okay. If I was actually going to pick a sample, I'd probably use my calculator because 50 is a lot to pick, and a calculator can do it really easily, right? But again, like I said, there's other methods to do it. Names out of a hat. Okay. So before we do any of that stuff, what do we have to do? Number each student, however you decide, 1 to 50, 0, 1 to 50, or you can go 0, 1 to 99. You can give each student, oh wait, no, not 50, 100, yeah. Okay. So if you're going to use the random number chart, you probably would do 0, 0 to 99. But if you're going to use the calculator, is 1 to 100 is fine. Okay. I use the calculator one on the last one. I'm going to show you a different method. I'm going to show you the names out of a hat. Okay. You can do names out of a hat. Number each student 1 to 100. Put 100 pieces of paper into a hat. Select 50, which will go into your treatment group. Next 50, go into your control. Like I said, if you were actually going to take this sample, I wouldn't do it that way because it's take a while, but it's another way of doing it. Put 100 pieces of paper in a hat, select your first 50 that go into one, the next 50 go into the control group. Okay. Replication talks about numbers. So we want to talk about numbers. We want to say 100 students total. I'm guessing these students volunteered. 100 students volunteered, 50 in each group. Okay. Control. So we have to tell who are the control group. So classroom group was the control. Okay, classroom group was the control. What else? So one thing I forgot to label, but you definitely want to put in the control, is what are we comparing? How do we know one's effective over the other? So how are we going to know one was effective over the other? We're going to compare average SAT scores for the groups to determine most effective. Okay. That's how we're going to know. So here I have a question. What if the average SAT score, is SAT still go to 1600? Was it the high score? Okay. It changed for a little bit, but then I think it came back. When I was in school, it was 1600 was the highest, but then it went up to like 2400. Now it's back to 1600. Okay, so let's say one group, let's say the online group, their average was 1150. And let's say the other group was 1175, the classroom group. So the online was 150 and the classroom so obviously the classroom's higher, right? Does it mean it's better? Does that mean we should switch everything? Let's switch everything to classroom. No more online. Let's only do the classroom. Well, no, there's 50 and 50. 50 and 50, right? We said 50 and 50. Mm-hmm. Okay, so let me how do I put this? Yeah. Exactly. What you guys are getting at is it's not that big of a difference. 25 points, right? 25 points is not that big of a difference. Okay, so let me change this one. How about worth getting rid of the online? Okay. Worth getting rid of the online? Now you guys are getting a little more close, right? Now worth getting rid of the online? Yeah, now we're finally got to there, right? Here's my question. When is it significant? When is it a big enough significant difference where you're like, yep, online, you're done? Is there a number? There's only one context, is test scores. There's only, right? 1600 is the best. When do I say classroom is significantly bigger than online, get rid of the online? Well, here's the answer. There is an answer, but this is what we're doing next semester. Next semester, there will actually be a number that says this guy is not only big, but it's significantly bigger than this guy. Okay? That's all we do next semester. All we do next semester is compare. Here are the numbers. Compare them. Is one significantly higher? Well, 1400 is bigger than 1150. You don't need to be a rocket scientist to see that. But is it big enough so I can say get rid of online? Right now, it's kind of a judgment. You're like, next semester we'll get more scientific with it. We'll say, yes, it is significantly bigger, or nah, not quite. Okay, that's what we do second semester. We make those decisions. First semester, we gather the data so we can make those decisions. So next semester is all about making decisions. Now, you don't need to make that choice. You don't need to make that choice yet. We'll do that next semester. Okay, but that's how the class moves. This semester, we're just working with data. How do we gather data? Here's the data. Next semester, actually have to make decisions. Okay, that's what we do. Okay, all right. So next time we'll do a couple more examples, and then I'll let you guys start on the assignment. Okay.